Greetings of the day. Welcome to the course on Operations Research Technique. In previous lecture, we have seen fundamental aspects of project management. There we have studied what do you mean by PERT, Program Evaluation and Review Technique, what is CPM, that is Critical Path Method. We have also studied difference between PERT and CPM. Along with that, we have studied what is activity, what do you mean by event, and how activity and events are represented in a systematic graphical representation of a project, which is referred as network. So now in today's lecture we will see in depth how analysis is done for PERT and CPM. So let's start the today's lecture with one simple network in which I will explain each and every point and how the various calculations are involved in any network. So let's start today's lecture with this network. Now what I will do is I will draw one network, and through that network I will explain all possible concepts involved. So let's start with I am drawing network arbitrarily based on my experience, and we will see what are the various technicalities involved in any network. So here this is the network I have drawn, a simple network. Now this network consists of 1, 2, 3, 4, 5, 6, 7, 8 activities. This network consists of 1, 2, 3, 4, 5, 6, 7, 8. In earlier lecture, in previous lecture, we have studied what do you mean by activity and how we represent activity, and I have also mentioned network flows from left to right because time flows from 0 onwards. So from starting point, when I want to indicate progress of any project, I will move in forward direction from left to right. And if you recall, I have said something about Fulkerson's rule for numbering the events. So here in this example again I will explain how to number these various events. These circles are nothing but events. Circles are nothing but events. So again, to clarify, this is the representation of activity. So any activity, suppose I want to represent, it is represented by straight line arrow, and this particular circle is nothing but it is event. So this network which I have drawn consists of events and activities. Event is also referred as, we have discussed in yesterday's lecture, it is also referred as node or event by circle, and activity, a straight arrow is represented by activity. And if you recall, yesterday we have seen that activity's name is written above arrowhead and their timings are written below arrowhead. Suppose now for this particular case, time we are considering, suppose for example in days, units of days, and hypothetically I will write now name of the activities, let it activity be A, this be the activity B, this is activity C, further this is D, E, F, then G and H. So what I did is I have written rather I gave names to these various activities. And now what I will do again, I will write the times of, again this is arbitrarily the time taken by these activities. Suppose this is taking, A is taking 10 days, B is taking suppose 7 days, C is taking suppose 9 days. This arbitrarily I am telling you. Now here suppose this D takes 20 days and this takes 15 days. F takes suppose 10 days. G takes suppose 7 days and H takes 8 days. So what I have shown is a network, simple network, where I have labeled various activities and time duration for these activities in days. This is for understanding purpose I have drawn here. So these units, whatever alphabets I have written, is time in days. Activity is represented by straight line arrow and event is represented by circle. Now yesterday we have seen numbering the events. So what we will do is we will now number the event. So Fulkerson's rule, if you remember our yesterday's discussion, what I have said is start from left to right, and in second case go from top to bottom. So this was regarding Fulkerson's rule. Fulkerson's rule for numbering the events. And I have said that first count the number of events. So 1, 2, 3, 4, 5, 6, 7. If you recall my yesterday's lecture, starting event 1, last event we have counted event 7. So last event by default will be 7. So no hesitation. There should not be any hesitation in giving numbers to these events. First event always initial starting number, last event number is the last number which we have counted. Now you may say, sir, is it binding that we should give the number as only 1, 2, 3, 4 like this? Is it standard? So students, remember, this is not standard. Somebody may give number to the event as 10, 20, 30 like that. So here instead of 1 you may write 10, you may write 17. But we know that it is simple if we write number in single digit. So what we will do throughout this session, we will write the number in single digit. Wherever there are more events exceeding 9, so we have to enter into the double digit. If it is the big complex project of more than 99 events, then definitely you have to have the event number 3 digit, that is 100 and above. So what we will do is we will start numbering the events from first numerical, that is 1. So our rule is left to right, top to bottom. Initial event is that event, yesterday I have explained, initial event is that event which is having only outgoing arrow. So this is having only outgoing arrow. Terminating event or last event is that event which is having only incoming arrow. This event has only incoming arrow. Now what I have explained in my earlier lecture, while numbering subsequent events, again I am reminding, while numbering subsequent event as per Fulkerson's rule, see that that particular event has only outgoing arrows. Now you may say that, sir, how it is possible that in between events will have only outgoing arrows? It will also have incoming arrow. Yes, you are right, true. What I have said again in my yesterday's lecture, that put your palm on the incoming arrow to that particular event, assuming it is deleted, and see whether it has only other outgoing arrows. But your motion should be left to right, top to bottom. Now I have numbered 1, I have numbered 7. So what we will do? Now here I can see that this particular event is having this incoming arrow and this outgoing arrow. So what methodology is there? Fulkerson's rule says, put your palm like this. So now you cannot see this incoming arrow. This is visible only in the form of, this is only visible in the form of outgoing arrow. So this number is to be immediately numbered after 1, that is 2. Now suppose here intentionally I do one thing. Suppose I give this incoming arrow like this. This is a very important aspect. And if I put my palm over here and say this, now suppose I want to decide, it is what we have written is D10 I have written. If I omit this particular arrow, then this particular event is having this incoming arrow which just I have added and outgoing arrow. So students, remember here I cannot number this event as 2 because this is having this outgoing incoming arrow. Now what I will do? I will go do this. So this is having this and this 2 outgoing arrow, no incoming arrow. So this will be labeled as 2. Similarly, this will be labeled as 3, and then this will be labeled as 4. Suppose this arrow is present. Got it? Very important concept. Now what we'll do? We'll omit this particular and we'll go by our original concept, original diagram like this. So what I will do is 2, 3, 4. You have to follow the rule. 2, 3, 4. 4 is on. Then immediate next number for rays emerging from 2 and 3. So this is 2, 3, 4, 5 followed by 6. So this is the way how we have numbered this particular project by Fulkerson's rule. Got it? Now see, this is the project which consists of 1, 2, 3, 4, 5, 6, 7, 8 activities. Again 1, 2, 3. This is not activity. This is wrong. This activity is earlier we have written A. This I have written as B. So 1, 2, 3, 4, 5, 6, 7, 8. This is the project consisting of 8 activities which are to be performed in logical sequence. Yesterday we have seen what is the logic. So the meaning is we cannot start activity G unless and until this is not this activity G, unless and until we complete activity D and E. Similarly, F can only start once you complete C, like that. Now this is starting point of the project, this is end point of the project. Anyhow, we have to reach from, now I am on very important aspect. We have to reach from 1 to 7. We have to reach from 1 to 7. See what I am telling now, very important aspect. So for reaching from 1 to 7, looking at this network, I have various paths. I have various paths in this particular network which start from 1 reaches to 7. So what are those paths? The paths are 1 2 5 7. 1 2 5 7 is one path, correct? 1 2 5 7 is one path. Second path is 1 3 5 7. 1 3 5 7. And third path is 1 4 6 7. Third path is 1 4 6 7. So these are the various paths available to reach from 1 to 7. We are not interested in all these paths. Of this, we want the path which is, as per yesterday's discussion, which is critical path. And definitely out of these 3 paths, one path is 100% critical path, and activities lying on that critical path will be referred as critical activities. Rest of the activities, barring critical activities, will be termed as non-critical activity. And whosoever is the decision maker has to focus attention on critical activities, because delays in critical activity is not permitted. You cannot allow any delay in critical activity. Got it? Let's move ahead. Now, first get the importance of various points. So for that I will rub this particular write-up. Now see, this event 5 will be assumed completed if I am talking of event completion of event 5. Concentrate my sentence. I am talking on completion of event 5. Now event 5 has 2 activities terminating D and E. So event 5 is assumed completed only if, very important, only if both D and E are completed. See, you cannot start activity G if you finish activity A and D and yet E is yet to complete. If one say, what happens if I reach to 5 by path A, D, E is yet to complete and I will start activity G. That is not permitted. That is not permitted in network management. This event will be assumed completed only if all activities terminating to that event are over. Then only you can start subsequent activity. Same case over here, unless and until C is completed, F cannot start. And we know that last event is having only incoming activity arrow. One thing also you must keep in mind, very, very important. Whatever complicated network may be, in the real scenario also I am telling, in the real life scenario, whatever may be the complications of the network, let there be lakhs of activity to the network. I am saying lakhs of activity to the network. Any network, underline this statement, any network will have only one starting event like this and only one terminating event like this. Any project will have only one starting event and only one terminating end event. You cannot have a network like this. Many times students do like this. Many times this is the common mistake which students commit. Two starting, totally wrong. Or student do other blunder like this. Two ends. And they say this is the network. Students, this is wrong. This is also wrong. So keep one thing in mind. Underline this statement. Whatsoever is the complication of the project, any project will have only one starting event, only one end event. That's all. Other important point I will tell now. Very important. Suppose just now we have said that it will have only one starting event. Starting event may have one or more than one activities which can start at same time. What I said? There cannot be more than one event. That is true. But the starting event, depending on the project nature, may have only one starting activity or may have more than one starting activity. This is the point which I want to emphasize. Similarly, terminating event or end event will have similarly this end event will have maybe only one terminating activity or maybe more than one terminating activity as shown here, or maybe two terminating activities as shown here. This is very important tip, students, which I have given you for network drawing, correct drawing of the network. Now, what is more important? What I said, I have to reach from 1 to 7. If I follow this path, this is 10, I reach here on 10th day, this is 20. So for this AD route, A to D route, 30 days I take to reach to 5. By BE activities I take 7 plus 15, 22 days to reach 5. Very important aspect. Now the problem is, by this 1 to 5 route, it takes me 30 days to reach to 5. By BE route, it takes me to reach 5, 22 days. Now here I am having two values. One is 30, other is 22. at event number 5, and event number 5 is assumed completed only when all activities terminating at 5 are over. So definitely I have to consider 1, 2, 3, 4, all 4 activities. Means I have to consider all 2 routes. This is 1 route, this is 2 route. The longest route is 30 days. I cannot start activity G. I cannot start activity G on 22nd day or after 22nd day. I have to wait till 30 days. Means no doubt I have completed this task 8 days prior. I have to wait. I have to keep calm. I have to keep calm because this activity is yet to finish, and this is assumed completed when this D will be finished. And therefore, students, what value we will be considering for further analysis is 30 days. Got it? So, in this forward direction calculation, what we are considering is maximum values. Maximum values. Similarly now, for consider to reach from these paths to 7. So now I have reached up to 5. So 1, not 1, 5 onwards. 5, I want to go from 5 to 7. Time at 5 is 30 days. It takes 7 days. So one answer for me is 37 days to reach at 7. If I consider this path, suppose I consider this path, so it is 9 plus 10, 19, 19 plus 8, 27. So by path CFH to reach 7, your time was 19 plus 8, 27. So now here for final destination you are having 2 times. One is 27 and other is 37 and other is 27. Now the question is, can you say that project is completed on 27th day? Because I have reached destination 7 on 27th day. But remember in mind, this is yet to be finished, and therefore you cannot complete, say this event number 7 is completed. This will be completed, assume completed only when both G and H are over. So students, again I am highlighting, when we are going for this forward time curve, what we have noted is maximum time. For the time being, we will keep this thing in mind, how we take various times for the project. Now what I have tried to explain is various paths and the logic, how this project can be said, or at which point of time this project can be said completed. With this background now, I will enter into technicalities. With this background, this is the general idea which I gave to you. Now we know that this particular event 37 days will be, this particular project will be completed by 37th day. Now suppose I talk of any activity for a project, and we know that this is one event, this is other event. Yesterday we have seen this is I, this is jth, this is straight line arrow, and we have said this is nothing but this is representing activity. This is representing activity. This is what is event, and this is also is event. Now this event and this event has two times. One is earliest start, earliest completion. Next is latest start, latest completion. That aspect, that technical aspect now we'll study. So let's move to that. So if you recall, in our yesterday's discussion, we were at this point. Every event will have one earliest occurrence time or earliest start time. It will have latest allowable occurrence time, latest completion time. Now focus your attention on these two terms, very important terms. ESIJ, which I have written TE, that is early starting time for activity IJ. TE, here I will write TEI. One I will write TEJ. Similarly I will write TLI, TLJ. This is very important, students. Earliest start time for activity, for event rather, I. Earliest completion of J, latest start of I, latest finish of J. With this background now, this is the wording statements I have given for your understanding. I will be elaborating through these variables in case of a real problem. So focus our attention on these variables TI, TEJ, TLI, TLJ. So TE earliest time, E earliest, L latest. Latest start, latest completion. Earliest start, earliest completion. Got it? We have to focus on two words. First is earliest. In that two, start, finish. Similarly, latest, start, finish. Let's move ahead. Now what I will be doing, we'll adopt one methodology of representing our event, and we'll follow that. This is the event. What we will be doing? We'll be dividing this event into 4 parts. Here we will be writing event number, Here we will be writing slack. In this corner we will be writing TE. In this corner we will be writing TL. Now event may be your ith event or it may be your jth event. If it is ith event, this will be TEI. If this is ith event, it will be TEI. If this is ith event, this will TLI. Slack SI. But if this is suppose jth event, if suppose I write this as jth event, then what I have to do here is, this is J, this is also J, and this is SJ. This is the simple convention we have to remember. And why I am giving this nature of node or event representation? Because it is easy in calculating. And what we have to remember, we have to do our calculation in two aspects. One is called as forward pass calculation, and other aspect is backward pass calculation. When we carry out forward pass calculation, we go from left to right, that is from start to end, from start to end, and we go for backward, we go in this direction, that is from end to start. After doing these two calculations, we then find the value of slack for each event, and after finding slack we find critical path. So this is the flow when we analyze any network. We will be representing various nodes of the project by this diagram. This concept will be calculating forward pass time, backward pass time, slack, and then we will determine critical path. Moving ahead. Now, just I have mentioned forward pass, and here for earliest event time. If you recall previous slide, TE, there this E stands for earliest, T stands for time. E stands for earliest, T stands for time. It may be TE of I, it may be TE of J, TE of I or TE of J. Now, in previous example, simplified network, we have calculated various times wherein 8 activities we have considered, and I have explained that when you go in forward direction, out of those times we take maximum time. So we have proved in that particular network why maximum time is to be taken. So based on that, what we studied through that example, in forward pass calculation you have to use this particular formula for calculating TE of J. J is successor activity, maximum of time available of TEI, this is predecessor event, activity time, this is activity time, You have to add activity time to the time of predecessor event to get this TIG. If you are having more than one value, choose maximum value. This is very important. Choose maximum value. Why to choose maximum value? That we have seen in that example. Similarly, when you come across backward pass calculation where you want to find latest allowable time, you have to adopt reverse technology, reverse concept, that is going from end to forward, and wherever you are having more than one value in your backward calculation, you have to select minimum value. You have to select minimum value at junction where you are getting more than one value in your backward calculation. So remember, forward pass, in forward pass we are interested in maximum value, and in backward we are interested in minimum value. Then only we will get the values of slack for particular event, and we will be in a position to find critical path. Again, this concept I will explain while finding these values in actual problem. So, two types of calculation: forward pass, backward pass. In forward pass, maximum time. Wherever more than one arrow terminates into the event, you will get more than one time. In forward pass, you have to select maximum time. So that time is nothing but it is summation of time for activity under consideration and previous event. Similarly, in backward pass, you have to find latest time. In that, wherever you get more than one values, at tails of arrowhead, there will be selecting minimum value. Keep this point in mind. Now let's move ahead. Slack. First, what we will do, we will study all terminologies, all variable required, and then we will switch over to problem that will be easy for understanding. Now, slack for an event, it is a very important term, very important in network management, project management. It is the difference between latest, what it says, it is the difference between latest occurrence time, that is TLI, and earliest occurrence time, that is TEI, of the same event. If there is no difference, it will be 0, and it is assumed that that particular event is having 0 slack, means no deviation in the time allowed for activity, or activity under consideration will not be permitted to take more time than its expected one. Now with this blue color I have shown the significance or importance of this slack. So it is a measure of how long an event can be delayed. How long an event can be delayed without increasing the project completion time. Say students, very important, once the project planner defines the targeted period, because what happens when project is planned on the paper, we know that project involves a lot of activities, and these activities are to be performed in some predefined order. And when we say that these are to be defined in performed in well defined order, we also know that activities consume time as well as resources. If we delay the project due to one or other reason, the cost of resources increases, and it will have impact on inflating the overall cost of the project which you have planned, which you have quoted at the time of planning phase. So that is not permitted in project planning, in project management. So your intention as a project manager should be to complete the tasks without delay as per predefined schedule. That you have to keep in mind. So now if there is no slack, means there is no permission of delay. But if there is slack, then we can delay that activity by some amount. And last is critical path. The path of longest duration. Certain activities in any project are called critical activities because delay in their execution will cause further delay in project completion time. All activities having zero slack, this is very important, zero slack are identified as critical activities. And on critical path, this is, we will see in further lecture that on critical path we will get this relation, and critical path will be the path of longest duration. So here we will stop this lecture, and in next lecture we will start from this slide and we will go ahead, and there we will solve one problem. So I am ending my today's lecture at this point of time.